Hello there, I'm honored that you could join me. I was just admiring this periodic table. It evolved from the brilliant observations of Russian chemist Dmitry Mendeleev, who, in 1869, discovered that when the elements were arranged according to their atomic weights, their properties would repeat periodically. What's so amazing is that it captures on a single page the atomic building blocks of just about everything we can see, touch, taste, and smell. The vast majority of these elements, or atoms, can combine with, or bond to, other atoms to form molecules. Those resulting molecules can then react with other atoms or molecules to form different molecules. This process is referred to as a chemical reaction. Today, we'll explore one particular chemical reaction which you're probably familiar with. It involves two common household chemicals, namely, baking soda and vinegar. Many elementary school students have used these two chemicals to simulate a volcanic eruption for their science projects. There are 4 different elements involved in this reaction. They are hydrogen, which has the lightest atomic weight of all the elements, and therefore is the first element on the periodic table. The number in the upper left corner indicates the number of protons in the atom's nucleus, and the number at the bottom is the atom's relative weight, commonly referred to as the atomic weight. Next is carbon. The third element is oxygen. The last and heaviest of these 4 elements is sodium. So, now that we know which 4 elements are involved in the reaction between baking soda and vinegar, let's have some fun by making the reaction happen. Let's start with some baking soda. Now, let's add some vinegar. Now, let's have a look at what's happening on a molecular level. These are molecular models. The one closest to me represents baking soda, also known as sodium bicarbonate. And the other model depicts vinegar, or acetic acid. The small white balls represent hydrogen atoms, the larger blue, red, and black ones depict sodium, oxygen, and carbon atoms respectively. As the name implies, acetic acid is an acid, while sodium bicarbonate is a base. So the reaction between vinegar and baking soda is considered an acid-base reaction. Typically, in an acid-base reaction, the acid contributes a proton to the base. A proton is essentially the nucleus of the hydrogen atom. So the vinegar molecule loses the nucleus of the hydrogen atom that's attached to the lower oxygen atom, while the sodium ion from the baking soda molecule takes its place. Meanwhile, the hydrogen-oxygen pair, or hydroxyl group, from the former baking soda molecule detaches and bonds with the proton. What we're left with is a water molecule, carbon dioxide, which is a gas and is responsible for the bubbling action, and a salt, namely sodium acetate. So we started with 2 molecules and ended up with 3. You can think of chemical reactions as a rearrangement of atoms or groups of atoms between molecules. All acid-base reactions follow this same basic mechanism. There are many different types of chemical reactions, each of which follows its own unique mechanism. I hope you found this short video helpful. Thanks for watching, and I look forward to seeing you in the next video. Have a great day.